So here's example problem 2.19 out of the book, page 66. I just figured I'd go through it a little bit more clearly and see if we can explain how you would solve a problem like this. This is an equilibrium problem, so the first thing that you need to recognize is that all the forces acting on this object must add up to 0 since it's in equilibrium. The object weighs 98 newtons, that's the vertical downward arrow, and it's being held by two strings or two cables, and we're meant to find the tension in each cable. So one of the things to realize here is that cable T and cable S can be broken down into their X and Y components, how much force they're exerting in the horizontal direction, how much force they're exerting in the vertical direction, and you should also recognize that the Y direction, T sub Y and S sub Y, they're pulling up, that has to equal 98 newtons, which is the downward pull. And then the horizontal pulls, T sub X, has to equal S sub X. Or they don't have to equal, I'm sorry, because they're different angles, but they need to add up to 0. So we need to do some trigonometry here. First of all, you have to recognize that the angles that these cables make with the horizontal are 30 and 50 degrees. That's basic geometry. And then we'll do some basic trigonometry. So here I'm going to create an equation for the vertical components and set them equal to 0, or equal to 98 newtons in this case. So here's my first equation, t sine 30, which is the vertical component of t, plus s sine 50, the vertical component of s, is equal to 98. So that's the upward forces equals the downward forces. That should work. I'm going to do the same thing with the horizontal forces. So there's my equation for the horizontal forces, negative t cos 30, since t sub x is going in the negative direction, plus s cos 50 should add up to 0. Great. Let's rearrange equation number 2 and solve for the variable s. So there is my rearranging of equation number 2, solving for the variable s, which says that s is equal to t times 1.3473. I can now take this and plug it into the first equation and solve it for t, and then I can go back and solve for s. So that's basically how that problem works out. I'm not going to run through all the details for you. The answers are in the book. They actually walk through the solution on how to do this. It's on page 66 of your textbook. Give it a try.